How will the AI revolution shake up the way we move bits around the world? And what does it have to do with data freshness? How will the shift from AI training to inferencing that's going on right now impact networks at various scales? Why does it matter where your closest internet exchange point is geographically located? And how do people in the industry define words we often use like data center, colo, carrier, hotel, internet exchange point? And why does precision with these words matter? Well, welcome to Telegeography Explains the Internet, the show that explores the business behind all of the ways humans stay connected around the world. I'm your host, Greg Bryan, and we are in the midst of our series focused on all of the ways that AI is impacting the telecom industry. And to help us answer these questions and many more, my guest today is Hunter Newby. Hunter is a true veteran of the industry with a career spanning over 3 decades, from the early days of WorldCom to becoming a pioneer in the world of carrier hotels and meet-me rooms. And now, as you will hear, he is facilitating the inference revolution from the network infrastructure side. In this episode, we're going to dive into the physical reality of the internet and why the next phase of AI really depends on it being in place. We discuss the shift to inferencing, why the industry is moving from massive training, power-hungry data centers to low-latency inference points that need to be close to where the people and machines actually live. He talks about his fresh bread analogy. He explains why data is like bread. It's worth the most when it's fresh because of low latency, and it loses its value when it gets stale. We talk about decentralizing the internet, why Hunter is building a new neutral internet exchange in Wichita, Kansas, and why 125 other edge markets in the US desperately need their own local interconnection points. We talk about layer 0 reality on the 7-layer OSI scale. It's important to remember layer 0. Hunter gives us this reminder that while everyone talks about software and AI further up the stack, none of it works without the plumbing, the manholes, fiber, physical meet-me rooms, etc. This is a fascinating look at why geography and physics still dictate the future of our digital world. If you enjoy the show, please rate us on your favorite podcast platform and subscribe so that you never miss an episode. And if you found this conversation insightful, tell a friend to listen. You can always find me on LinkedIn. I love to hear your suggestions and feedback for future guests. Okay, on to a fascinating interview. Welcome to the show, Hunter.
Thank you. Great to be here.
Yeah, absolutely. So, Hunter, when I thought about having you on and pulling you into this AI series, I was looking back at old emails, and I think I was introduced to your work almost like 20 years ago when you were starting Allied Fiber. So you have this, and your history in the industry goes way further back than that. Why don't you just give us a little bit of a taste of your role in the industry over the last few decades here?
Well, thank you, Greg. So I came out of LDDS WorldCom in the 90s in New York, where I learned how not to do everything. I was just
It's important to learn those lessons early too, right?
I was thrown into the juggernaut and the mosh pit at the same time. Just to keep it brief, the issues were really about lots of M&A of different networks, but the lack of integration of those networks, not on the balance sheets and the consolidated EBITDA, but at the physical layer. So basically, how do you provision circuits across disparate networks that you've just acquired? And those types of things take, months and years to plan and execute. And it was very difficult and frustrating to get one circuit from one network to deliver, an ALOC to another, network ZLOC. And I was, spending a lot of time at 60 Hudson Street in New York City at that time. And it sort of just dawned on me that, everything's here. All the networks are here in different rooms, and they're owned by different companies. And some companies acquired different networks, and they're trying to figure out how to even get connected in the same building to each other, which was hugely problematic. And then, from that, I was in the international wholesale voice minutes business, origination, termination, but also in the dawning of the public internet. So, WorldCom had acquired MFS, which had UUNet, and I learned a lot about the public internet from the UUNet engineers that actually built it, that were still there at the time in the 90s. And I was that one, that the person that called and pestered them and asked them all sorts of questions, like what is OSPF? What is BGP? What does this mean? How does that happen? That was in around 96, 97, 98. And then I left WorldCom and I joined the predecessor company to Telex, which was in the minutes business. So basically buying and selling originating voice, wholesale voice, coming out of New York in the 90s, the calling card era, call centers, bodegas. That's a whole different podcast.
Yeah. Then the internet rears its head like at the end of the 90s and
98, 99, 2000.
Yeah.
So then the voice over IP became a thing. And basically the internet moved into our physical world, our TDM Sonnet world. So everything went from T1s and copper, towards Ethernet and IP. And then the underlying optical infrastructure went from Sonnet to DWDM. And by 2000, we created Telex Group Inc. And Telex Group Inc. was a real estate holding company, basically. It was the tenant in 60 Hudson, but then we had licensed tenants of our own, let's call them. They were network operators. And there was a lot of logistics of figuring out how to get, fiber networks in from the points of entry, from the manholes in the Empire City subway system, ECS, where all the fiber moves around the city, into the basement, up the risers, and to our floor, which effectively became the meet me room of the building. The terminology was born then. I started writing articles back then. In 2002, it was the first time I wrote a series of articles for Capacity Magazine, specifically about meet me rooms. So, you can go ask the AI today and it'll tell you that, like the OG that goes all the way back to the time before the time. And then from that, my understanding, studying the long haul fiber route maps of the US, finding the other 60 Hudsons, and then setting out to go acquire them all was my little private game of Monopoly. I wanted to own Boardwalk and Park Place in the game of carrier hotels.
Yeah.
And I also focused on North Atlantic subsea, which was really important. At the time, there were 7 North Atlantic subsea systems, and I made it my business to have them all physically present in my facility, which started with TAP 14 and Deutsche Telekom, which was my largest customer, our anchor that really made Telex become what it was. And then all the networks coming from Europe would come over on one of these systems and come out in our room, basically, not at a landing station in Long Island, New Jersey, but physically come out in our room in 60 Hudson. We were like the Ellis Island of telecom.
Right.
JFK, whatever you want to think about like that.
And it's worth mentioning at that point, just in terms of history for folks who weren't around then or weren't involved in that kind of thing, that at the time, a huge share of all of the global traffic went along that route, right? Oh, yeah. So since then, we have greatly diversified the sub-cable paths and everything around the world. But back then, that route was sort of the core of exchanging data around the world, basically.
Absolutely. And must give props to telegeography. I mean, the telegeography submarine cable map, to me, that was like the Bible. I used to tell people, right, I still do. I always had a submarine cable map from telegeography in my office, framed, or in any of the different carrier hotels where there were actually submarines present, like 325 Hudson Street, which I became a partner in years later, where the flag system was. And I would point at the map, and I would say, when I close my eyes, this is what I see. I see the submarine cables and these focal points, like these sort of neural dense interconnection points. And to me, the game was to own the real estate where those cables land. Because when you think about it in terms of ratios and value, the number of submarine cables, at that time, and certainly still today, that go into the ocean and connect to all the continents are the in terms of network number, the fewest in number. Terrestrial fiber networks, there are many more. So if you can capture a point from a real estate perspective that's neutral, very important, where submarine cables land, not CLS land, but actually backhaul to interconnect to other networks terrestrially, that real estate is the most valuable real estate in the world from a network interconnection perspective. There's no question. And I started focusing on that in 1999, which was, pretty, I think,
many people thinking about that back then. Yeah.
Significantly ahead of others. Yeah. So now, as you point out, there are new cable landing zones. If you just go down from New York down the coast. So it was New York, London, and basically that's how Africa connected to Latin America. It had to go all the way up
Exactly.
and around.
Yeah.
And I dabbled in all these things. I'm a partner in NJFX. Gil Santalese is the CEO. We put that together before 2015, but really started it and put it in place. So it's over a decade old now, and it was the first neutral submarine cable landing station that was ever built. We negotiated with bore pipe rights to what was Tata, right, which preceded that was Tycho submarine, and the beach manholes in the front hull, and and then we built our own building, which was Tycho 2, the design for the second building that Tycho never built. We built it, and it's called NJFX, and it's a neutral submarine cable landing station, and that concept has taken off, and others have done the same thing in different places. DC Blocks in Myrtle Beach is an example, and several others. And Equinix does that around the world. And then, of course, there's acquisitions of sites like that, like Interaction in Marseille that Digital Realty acquired, and others. Very, very, very important. And what I want to lean into that is that type of real estate or those very specific facilities, they're not data centers. People call everything a data center, and it's just horrific because now data centers are NIMBY, which is a problem for the industry. And I'm happy to say I stay away from that because I focus on network interconnection and not power first, and that's where all the LLM training gigawatt people went, and they're living in the situation that they've created for themselves. But when you get down to meet me rooms and carrier hotels, which is my background and where I focus, that's all about network interconnection. That's about multi-network density and proximity for the benefit of choice, and that it creates better pricing, better quality, better terms for all the buyers. And sellers go there because from a wholesale perspective, that's where they generate the most revenue and route diversity and whatnot. So in my current venture, skipping way over from the beginning to now, not naming a lot of other things in between like neutrality and Colo ATL, Fiber Center, but right now I'm building with Connected Nation. We started a new company called Connected Nation Internet Exchange Points, CNIXP, and we're building a new building in Wichita, Kansas. It's purpose built and designed for multi-network interconnection, neutral. And we obsess over manholes and vaults and points of entry and slack cable and and splice cases and things like that.
Right.
And
colo concerns rather than data center concerns.
Right. Colo is also sort of a murky word.
Right. Yeah.
It's like edge or whatever, and it's not as bad as data center because that now implies like lots of power, and that's where everybody's getting NIMBY. Where we can't say carrier hotel or meet me room in rural America, or they think
they think
we're in the dating business. They hear hotel, they think mattresses. So we refer to them rightly as internet exchange points because we house an internet exchange, which is operated by DKIX as a service. And DKIX is the largest internet exchange operator in the world by countries. And I have a long-standing relationship with them. But anyway, it's about bringing the quote-unquote internet to places where it isn't, like cities like Wichita. But now, what's most important, it's about bringing low-latency inference AI everywhere, where there's a population, where there's people and machines that need proximate data exchange on a low latency basis to run certain applications that require that. In places in cities like Wichita that don't have any structure for neutral interconnection, you cannot participate in low latency inference for multi-network. There's no place to do it. So that's what we're creating. We've diligenced the country. There's 125 cities, just like Wichita, not all the same, but similar, that lack a neutral point. And that's what we're building from the ground up.
Yeah, absolutely. So let's get into the core topic of today then in that sense, right? So since you brought it up, that, so far the AI revolution has been very focused on the model training in terms of the impact on the telecom industry, right? So a lot of what people have been talking about is massive fiber connections to these big GPU megawatt data centers, right? As enterprises get to the sort of actual adoption of these tools, which they are getting to now, right? And certainly a lot of things can emerge about what those tools really look like once we get to the sort of killer app versions. But inferencing is going to be certainly a very latency sensitive kind of activity. So from the enterprise perspective, right, when they're actually using these things, take us through how important latency and inferencing are, and why that needs to impact the telecom business itself, rather than just, we're talking so much about AI and massive data centers, but there's this big impact that we're going to see on telecom networks all the way down to the office level, right?
Yes, it's already happening. And of course, I'm really happy about that, because I've been talking about proximity and interconnection for, my whole life.
I was going to say, I always say in the AI discussion, all of these things have always been here. Bandwidth needs, latency have always been at the office level, right? But AI is just almost like sort of like, on steroids, sort of superpower that, right?
Yes. So again, there's like sort of ratios, right? Like how much meet me room space actually is there relative to how much data center space is there. It's a small part, but it's a very important part. It's the cotter pin that holds the wheel on. It's not the tire, but if without the pin, the wheel falls off. So without the neutral interconnection points, all the data centers that hive and sort of tether and satellite back to those meet points. And here we have a lot of people that think they secured land and power, and they, went to committee and called capital and broke ground and spent a lot of money. And then they didn't even think about fiber. They think fiber's everywhere. Oh yeah, fiber's just going to come and it's in the ground, dig a hole, it's there. No, it's not.
I was on a panel at a data center conference, and I brought this exact point up, and there was a guy on the panel who was like a data center kind of guy. We could dig trenches and build fiber. I'm like, that's,
good luck.
Okay, go for it.
There's a thing called rights of way.
Right. Yeah.
And you have to secure those. And by the way, distance. So you got to build a long haul fiber route to splice into a long haul fiber route, if you're allowed to, that takes you to a peering point that you don't even know how many optical miles away it is.
Exactly. And what ASNs are even available there, and then what your middle mile looks like, right?
Have a nice day. This is where people that think that they build network infrastructure because they build buildings actually learn that they don't know anything about the internet or the OSI model or any of these things, RTD or RTT, ASs. But to your question, inference is here now. The pendulum has swung. And if I could pick one thing that's happened that's in the big, broad sphere of all things, it's when NVIDIA did the Grok license for the LPUs. And I have historically not really, I pay attention to optical equipment, and, I've always been, a fan of like JDS Uniphase and things that happen at the, silica level or chip level or wave level. I pay attention to those things. But servers to me were really just beyond what I cared about, because I didn't want them in my facilities ever anyways. I care about DWDM, Ethernet core routers, and lots of fiber panels. But the Grok license was an indication to me that NVIDIA, and particularly Jensen, knew that GPU was training, and that was sort of that. And now we're getting into low latency matters, inference matters. And if you look at, the founder of Grok, comes from Google and what he did there, which only what I've read, I don't know them. But the LPU is very focused on low latency. And we have to be very careful, okay? This industry is full of words that everyone uses, and they all mean different things to different people.
We call this show Telegeography Explains the Internet for this very reason, so please.
I've actually written articles about this in the past, and I just looked it up through my own AI a couple of days ago, and I wrote an article about the definition of words in my part of the industry more than a decade ago. And it was like words like fiber and broadband, and they mean different things in every state. But when we're talking about latency, at a very high level, there's two kinds today. With GPUs, there's a latency, which is the GPU latency in the backplane to build cluster. And you could literally have a conversation with somebody about latency, talking about GPUs for 20 minutes before you realize that they're referring to InfiniBand. It has nothing to do with network latency.
Yeah.
So we have to clear that up. I'm talking about network interconnection latency. And then interconnection is another funny word. You could talk to somebody in the powered land part of data centers about interconnection. Their mind is solely focused on grid interconnection. And I'm talking about network interconnection. So the preamble to get it all out of the way about what the word that I'm saying means, et cetera. So when we get into the latency, we're talking network latency, network interconnection, which is actual optical network interconnection. And then you look at that Grok deal with NVIDIA, and you see that it's about the LPU, and then you see where they're going with their server configurations in terms of the rack size, the rack density, but the specific application they're designing and building it for, and that's low latency inference. And in order to actually effectuate that, you need to be in a facility that has multiple networks that terminate, let's say it, data traffic to IPs in that area. So that's, to your question, it's going to change the actual physical design of the internet. And then it's going to change layer 2 and 3 about routing in zones. I call them latency zones. So from an internet exchange point today, that, it stuffs over the layer 2 switch fabric, and there's VLANs, but people roll off and they do, what's called PNIs, private network interconnects, or we would call them cross connects, physical layer. As long as you're taking AI workloads, inference workloads off of these, LPUs and the other stacks, the GPU, LPU, NPU, TPU, every PU, over to routers that have IPs that are in that zone. And a zone is, let's just say sub 1 millisecond, 50 optical miles, sub 2 milliseconds, 100 optical miles, sub 3 milliseconds, 150 and just keep going out from there. The last mile ISPs will be able to reconfigure their routers to take in that traffic and terminate to their IPs in that zone, and they'll be able to charge for that at a rate that's higher than transit. Okay. So transit's bulk, like throw it up to God and hope that it makes it. Wherever your ISP takes and routes it, that's, via con Dios. Well, low latency inference needs specificity, needs deterministic routing. So I want to hand you my bits, and I'm not going to buy from this ISP over here at a wholesale rate. I'll pay you more than that to make sure that this data stays in these zones. That is what's emerging. It's going to teach people. And it's revenue based. It's not like, go do it for fun. You're going to get paid to do it. That's going to change fiber routes, fiber counts, where switches go, where routers go, where the handoffs happen. And these LPU racks will want to be as physically close to those points of interconnection as possible for the reduction of latency to make the workloads happen. What are they? There's a lot. I sent you a link to an article that just came out like yesterday about Akamai deploying GPUs to their distributed, interconnection locations. That is the first very clear indication of a legacy sort of CDN business moving toward, oh boy, we got to buy millions of dollars worth of GPUs and get it out there to have the product to sell, right?
And the mindset of that's their platform and how they view the internet, whereas it's changing radically, right?
The old CDN, caching. No one's talking about that. The AI is here. It's like how the internet came on top of the PSTN. Inference AI is coming on top of the internet, and it's pushing it down, and it's putting so much data on it that it's probably going to slow down to a crawl in some places. And a whole new internet, I think, physically needs to be built away from the old internet that has all different fiber counts and routing designs and cost structures, to be honest. But like, what are the applications? One that always comes up is robotics. Well, always, more recently than ever before, but it's good. And then we even have two different ways to look at that. Robots in a factory have a latency unto themselves, but then there are these robots that have to talk, and this is where agentic comes in, and get instructions from other AIs that are not in the factory, and they need that in some of the uses. They need that at a lower latency. So all this networking stuff, fiber in the internet, it's going to matter a lot about where those connections happen, and are they within the latency tolerances of the application that's being run. That's all.
Well, you have an analogy about this, right? The fresh bread analogy and the time to first token. Tell us a more detail about that.
So basically, data is like bread. It's worth something when it's fresh.
Right.
As it starts to get stale, it ends up on the discount rack, and then you feed it to the pigeons. Not all things are really important, but I think everybody appreciates fresh bread, a French baguette or Italian bread or sourdough bread. Everybody wants it fresh right out of the oven. It's hot. We pay the most for it then. It's been sitting around for a few days. Not so much. Chop it up. Maybe it's a crouton. Maybe the pigeons won't even eat it. It's not worth as much. So there are buyers of data, like, phone scrapes of keystrokes from mobile devices in cars that they collect, and they monetize that data. They sell that 400 different ways. Well, there's people that pay the most, and the people, entities, organizations that pay the most for data, they want that data immediately. Well, we could get into cars, and I'm not talking about autonomous driving. I'm talking about connected cars that move through zones that have towers and radios. They want to capture those keystrokes and those bits. And, the picture you just took a minute ago, the text you just sent, your location, everything as it's happening, not a week from now, not an hour from now, not 15 minutes from now. And they're willing to pay for that. So there needs to be a physical network architecture, and then logical layer 1, layer 2, layer 3 behind it that supports that can deliver that. And that's what's happening. That's the fresh bread sort of analogy. And as long as that bread is always fresh, that rate per bit, whatever it is, will always be there.
And that's the thing to really put a pin on for telegeography listeners, right? Which is that as long as I've been doing this, carriers, layers 1, 2, and 3 providers have been saying, I can't continue to offer service at these declining prices, right? That the fear of commoditization, you're suggesting here's the opportunity for significant premiums, right? But you have to have that infrastructure in place.
So there's two ways to look at that. Are you in the data flow, like who owns the data, versus are you the plumbing, right?
Right, and I'm talking about the plumbing even, right? So, because that plumbing, in order to deliver to the data provider, right?
Correct. So I'm a landlord, and I like to create really valuable things inside my room that cause people to have to come into my room to get connected to it. And I charge rent. I'm not egregious. I don't charge monthly recurring cross-connect fees. I never have. I don't believe in it. If you pay me my rate for rent and POEs and stuff, then there's no need to tax beyond that. I have some private equity friends that think differently about that, but in any case, we move on. So the plumbing, so I'm a landlord, so plumbing. Let's talk about that for a second. I never recommend public stocks, ever. I just don't own them, because I think the public markets are, controlled largely, and that, look at Robinhood and that whole thing with GameStop. Right. I mean, come on. Right. But if I had to say, I think there's one company that's going to do incredibly well, U.S. company, it's Corning. I think they're going to be killing it for a long time, because the fiber counts are going way, way up. And if you're in the plumbing business and you're manufacturing things, you actually make things, you're going to be selling a lot of those things. And fiber jumpers and fiber cables are, connectors and panels, that's going to be a boom for all of this, but particularly agentic, between GPU clusters, no latency, 0. And the proximity of buildings where they're going to build trenches and, Saturn missile battery, like 4-inch conduits. And maybe they even go beyond that, and they just come up with some new sort of enclosure that you could just have bundles of, multi-thousand count cables, in a trench. Carriers can't really participate in that. The port speeds in the backplanes of the new Cisco router are 1.6 terabit. There aren't any carriers that sell 1.6 terabit waves or 1.6 terabit Ethernet, in a metro long haul today. So there's this sort of leapfrog moment taking place where a lot of that needs to be connected directly, no latency. So, but companies that sell, like I said, fiber, for example, are going to do quite well. Now, where do the carriers fit into that? Massive amount of data in agentic. Inference is how they all are sort of interfacing with the last mile networks that get to the endpoints. And that's where the cable counts are going to increase. So the volume, the port speeds that I'm seeing right now, from the inference AI GPU as a service providers are minimum 400 gig.
That is mind blowing. And on a port, mind you, not a DWDM, but a port. Yeah.
Right. Yeah. Multi 400 gig. So 2 by 400 from multiple networks. And they're just starting to learn about IP interconnection, or what I refer to as inference interconnection, which is what used to be called peering. But inference interconnection is about commerce. It's about paying to terminate bits to the latency zones, to routers that say, we will configure these routers to deliver those bits to these routers, to these endpoints, these IPs in these zones. And that's all measurable, and you can monetize that. I don't think anybody in the last mile business ever really thought about going the other way. They're like, they take the subscriber and bring them to the internet. It's like, no, AI wants to get to the subscriber.
Yeah.
And this
Yeah,
is
absolutely.
something at a higher level. I think the Comcast Netflix situation from whatever it was, a decade or more ago.
Yep. The eyeballs versus content fight, right?
That whole debate is like old. This is a inference wants to get to the endpoint, which isn't necessarily an eyeball. It's a robot. It's a car. It's a whatever, a device, an IP, and to be able to have deterministic routing, guaranteed latency threshold, where it's going to be below this, you'll get that rate. And if they can think about it like that, I mean, it takes me back to my old international wholesale minutes days of arbitrage, origination, termination. If you could terminate a call to this, zone, this number, this, country code, whatever, city. In Mexico, they used to be bands. In the US, we had latas. I mean, it was all different, right? But if you could do that, and your call completion, which they called ASR, answer seizure ratio, if your call completion percentage was higher than 70%, and you could deliver this much capacity, we'll pay you that much per minute. This isn't new. This has been around for a long time. It's like the new wine in the old bottle or whatever, and you can reuse the bottle. So we have this new way of looking at how to route bits for the application that needs to get it there on time. And my other analogy, final one, is FedEx. Nobody even thought about, I have to deliver this package by tomorrow morning, and they invented it. And they spent a lot of money to build that. And then eventually businesses and others were like, oh yeah, I need this to get there tomorrow. So if you use the post office, you'd pay whatever it was, $1.30, whatever. And it got there whenever it got there. But if it absolutely had to get there by tomorrow morning, you paid $50.
That was their commercial in the 90s, right? So,
remember that, right? When it absolutely must have to get there by tomorrow morning. Well, if this bit has to get there in a millisecond, you're going to pay a multiple higher than what the, via Condios public internet can give you for a lot less. If that makes sense to people, good, because that's what this is. Someone's inventing that. It will be created, and then there is a use for it. People will buy it. Is it the entire use case? No. It's a ratio, like I said, even my part. I'm the smaller part, but very valuable, dense network interconnection. And then you have this all the way to the, thousands of acres, gigawatt, 10-year project that they can even get connected to the grid. What the hell does that have to do with what I'm building? Not much. Very extraneous. In here, network interconnection, low latency inference, that's where it's at today. And then soon come agentic.
Yeah, exactly. So some of this is still preparing the industry for what comes from the software side. We have to pay attention to what is happening on the software side. But I really think, to your point, that no matter what ends up exactly happening on the software side, what agentic AI looks like for the enterprise customer or whatever, there's no doubt that all of these things that you're talking about, the geography, ultimately matter. So I want to talk a little bit more specifically about geography, right? Because I love to do that on the show, obviously, right? I'm here in Northern Virginia, right? You're in New York, right? Enterprises that are in Northern Virginia and New York have a very different situation than enterprises who have sites all over the US. Will start there, but lessons are the same for the globe, right? Yeah. Your first project here is in Wichita. 125 other sort of edge markets that you're looking at. Take us through the thinking there, because people have always kind of thought, even to people in the industry, and I emphasize this on the show all the time, it's still the case that this infrastructure is often an abstraction, right? Especially to the AI guys. It's like, infrastructure is GPUs, right?
Yeah.
So why are you starting in Wichita, and where are you expanding from there? And when everything's in Ashburn anyway, right? So,
yeah. Well, I can tell you, Wichita's not in Ashburn, and Ashburn's not in Wichita. So
exactly, yeah.
People tend to take things for granted that they live within and don't realize that they have. Right. They bask in the glory of it existing and don't know that it does or why. But critical mass begets critical mass. So you could look at New York City, and people come to New York City. Why? Well, everything's there. It's opportunity, same kind of concept. And there's a lot of, onion to peel back to get to the reason why Wichita started. But my partnership with Connected Nation, which is fantastic, and their whole 25-year history, I encourage anybody to go look up who they are and what they do and the good work that they've done for 25 years, are still doing grant writing, FCC broadband mapping, advocacy, digital literacy. They donate laptops to the kids and they teach them how to use them, and others, and veterans jobs. I mean, so much goodwill, so much good stuff. And when I first met them, and I thought, well, this is the preeminent nonprofit that focuses on closing the digital divide. I asked them, to level set, like which carrier hotels or meet me rooms they'd been to, and had known about, because I've, been involved in many and know pretty much all the addresses, and they didn't even know what I was talking about.
Yep.
They were like, what's that? And I'm like, okay. Yeah. I'm like, do you know what an internet exchange is? They're like, nope. I'm like, okay. Said, maybe this is part of the problem. So I invited them to come to New York and gave them a tour of 325 Hudson, which was a building I was a partner in at the time, and helped redesign the meet me rooms and everything. Well, created them from the start. And we've sort of had a meeting in the minds there. Well, is it possible to replicate this in rural America? I said, well, let's see. And this is before COVID. Like, this is us thinking about it, noodling on it and whatever. And I'd built some new stuff in cities that never had it. Like you mentioned, Allied Fiber. I built my own ILAs every 60 miles in cities, like Fargo, Georgia, and Barnesville, and Warner Robins, and in Florida. They'd never seen a meet me room. They didn't know what that was, but that was deterministic based upon the long haul fiber route. I could control where those buildings went. So ILAs, I turned them into meet me rooms. But I've also done things, like in Canada, in Moncton, New Brunswick, in Fiber Center. They never had a neutral colo in the province of New Brunswick. And I figured out how to get the Hibernia submarine cable backhaul built into a building that I acquired and with a partner. And that's Fiber Center. So the local town was like, well, what is this? Right. They're paying Bell Canada $30 a meg for transit. Right. Not that long ago, right? Yeah. We introduced them to Hurricane Electric, and their minds were blown. Yeah. They're like, what's that? So that's this. But now it's like, well, Wichita, and the partnership with Connected Nation was born out of originally we worked together in Iowa on a contract the governor of Iowa had engaged them on to fix the broadband problem in an area which was related to an E-rate program. It's called Grantwood AEA. It's an area between Iowa City and Cedar Rapids. And I'd never done anything with E-rate, but I knew a lot of my tenants historically in carrier hotels, like 1102 Grand in Kansas City, for example. There were a couple of big network operator tenants that I had that were E-rate recipients. So I heard about it, but I didn't ever touch it because I was just the landlord. I just said, I don't care where your money comes from. Just pay your rent on the first, like whatever. We government subsidies or cash flow or whatever. So when I looked into it, I realized what was wrong with the E-rate program. In terms of network architecture design, all the schools buy transit from their school DMARC. Like a middle school or high school has a DMARC, and they get transit delivered there. And in certain cases, an elementary school, a middle school, and a high school will build a WAN, and then usually the DMARC's the high school. But it's still a problem, right? Because you're tied to a local loop, which means you have to get very limited provider choices, and then it's expensive. So I asked if we could move the DMARC. So I said, is it permissible for a school to bid out a transit circuit from a ZLoc that they don't own? And they said nobody ever asked that question before. Right, yeah. And the USAC was like, we'll get back to you. 2 weeks later, they called back and they were like, we can find no prohibition to what you asked. And I said, well, then that's what we're going to do. Yeah. And we aggregated all the schools to a point. So instead of paying $3.85 a meg, which is what they were paying at the school, we aggregated all the traffic to an address we chose. And we got 35 cents a meg from 3 providers. And it was a fascinating exercise to see that it was possible. And then I said, but I don't want to just do this on paper. I want to control the land, own the building, own the operating company, and bring in an actual internet exchange switch. Because price is one thing, but latency is another. And I was talking about that.
I was going to say, it's the middle mile problem again, right? Who are they connected to, right?
So my speech with them was Connected Nation. lowering the price is like giving somebody a cookie, right? Like, hey, but building a physical infrastructure that is the surrounding operating neutral colo business that is essential for the housing of the relevant ancillary operator network equipment that connects to that point.
Right.
You can't do that in a closet in a high school. You know,
Mm-hmm.
you have a switch, a router, whatever. They have their little whatever computer room. Is that going to become the neutral colo for the entire city and region?
Right.
All these
Right.
GPUs, everything going to move in there? No, the high school is not a neutral colo operating business. So we thought about it, started to formulate it, and then COVID happened. But we went through there still doing diligence. And I have to say, you know, what I mentioned before, when I started getting going in the early days at 60 Hudson with Telex, I studied the long haul fiber route maps, you know, the legacy level 3 Quest, Broadwing, all that. And it was an interesting thing. When fiber routes would leave a city, they'd take all different rights of way, different paths. But then when they would go to the next city, they'd all converge on the same address. So I just looked up their pop list and I found the other 60 Hudson. And instead of calling the owners of those buildings as a guy in New York in a competing business, which is how they would have viewed me and they would have hung up, I convinced a friend of mine who was a publisher of an industry magazine to let me write a monthly article called Meet Me in New York, Meet Me in LA, Meet Me in Atlanta, whatever. And I would call up the owners of these buildings as a journalist and say I wanted to write an article about them. And then they would tell me everything.
Right.
So the Meet Me series is still out there. It's legend. It's on my website. And that's how I made friends with these guys. I helped them design their buildings. I grew their NOI. And I said, the only thing I want in return is the day you decide to sell the building, call me and I'll buy it. And I'll pay more than anybody else. And that worked several times. So during COVID, I wanted to see where the largest internet exchanges were relative to the Meet Me rooms I featured 20 years ago.
Right.
And I got an API into PeeringDB, which is this big database of all the internet exchanges and facilities and ASs in the world. It's all user.
We use it all the time. Yeah.
I built this API into PeeringDB, extracted all the data, and me and my developer massaged that data into visuals, maps, charts, you know, things like that, graphs. And I was able to see that the largest internet exchanges in the United States were in all of the Meet Me rooms that I featured in all of those articles for 2 years I wrote. Now, how did I know? Well, critical mass begets critical mass, and networks go to where networks already are.
It's the network effect. Yeah,
right, exactly. It's a standard. It's a known thing. It's a card trick. So, but then something dawned on me. I thought about my Connected Nation friends and our discussion about rural America. So I decided to look at the inverse. Where are internet exchanges not? And this amazing map appeared. There are many states in the U.S. that have zero, not even one internet exchange.
Absolutely.
I'm like, this is probably interesting information for the governors of those states to wonder why economic development's not happening. And we try, but we can't attract big companies because, you know, there's the land, there's the power, there's the water, like the data center stuff, right? But then they say, oh, fiber. Yeah, we have fiber. What do you have? You have like the Cable Co. and Arbach or whatever. But you're 1,000 miles away backhaul from the actual internet, let's just say. So I shared that with them. And then we coupled that with their data. They have a very large GIS department and they do all sorts of mapping, obviously. And we put together a list of cities of minimum population size 200,000 that have a state land grant university, a regional airport. The K-12s pay more than $2 a meg. There's no IX, and it's more than 100 miles to the next IX. And then here comes the map.
That's your list. There you go.
And Wichita was on the list. So we applied for a middle mile grant with 4 other sites, so total of 5, to the NTIA, which we were not successful in receiving because the NTIA told us that they didn't understand our application. They failed to ask us any questions. Right. And then Wichita was very hell-bent on it. There was one person there. She's a visionary, Tanya Witherspoon. She built Innovation Campus on the campus of WSU. So to your point about enterprise, Innovation Campus, and really Wichita itself as a city has a legacy of being an industry town. It is an aviation and aerospace engineering town. City. That's what it is known for. So Boeing is there.
Yeah, Bombardier too. Absolutely.
They make parts for the planes. They do the engineering. So Airbus, North American Engineering Headquarters is there. Dassault is there. Spirit, Boeing, Textron that owns Beechcraft and Cessna. You got Bell. You got Lear. They're all there.
Mm-hmm.
But the internet's not there.
Yeah.
The internet is in Kansas City, Missouri, on the other side of the line in 1102 Grand, which I used to own and built the Meet Me room in. And with neutrality, well, originally Miramar, then neutrality, whatever, details. And then it either backhauls to 1102 or it backhauls to 910 West 15th in Denver, for the most part. There's a little bit that goes to 511 in Minneapolis and some to Dallas. But the state of Kansas lacks the local internet that everyone uses in it. They have to leave the state to get to it. That's a fact. So Wichita and Tanya and Wichita State University said, hey, we want the internet to be in our state. We want it to be in our city. Right.
Yeah. So
we did a deal. They wrote a state grant, which we applied for and won. We got land from the school on a 40-year ground lease, 1.3 acres. And we're in the midst of this. We broke ground in May last year. We'll be done this year, probably June, commissioned July. We're designing the manholes, the outside plant approach, the vaults, the conduits, the ducts, the building. And now we have just announced our big anchor customer, which is a neo cloud focused on low latency inference, which is QAI Moon. It's a JV between Cumulus AI and Moonshot Energy. And we're basically building a pod park, mini one, pod barn, where they're putting their AI pods in it. So we don't build data centers. We just basically we have a garage and they're putting these things in. It's very nice. It's not a garage, and it's tethered directly fiber connected to the exchange point, which DKIPs would sit inside of. And then the enterprises that are on campus, like Airbus and the rest, we've met with several times, Textron, they're very interested in connecting because they are, trying to send email to each other and they have rate limits on the file size they can attach. Yet they scan parts of planes and, the rate limit's 25 megabits, but the scan is a gig. They move them on thumb drives, so
like it's 1999. Right?
Well, look, they're doing really important work, and we're coming to help solve a local, mail server data exchange issue to keep traffic local so that it doesn't have to get backhauled all the way to Kansas City or whatever.
Right.
We can keep it there. And then this isn't just for the school, obviously. It's for Innovation Campus and the enterprise companies that are on the campus, but it's really for the city of Wichita. And it's
this has a knock-on effect for everybody. The enterprises that are there has a knock-on effect for the hyperscalers, right? The content guys, right? When we moved from you were talking about Akamai and the old CDN model, and when Netflix was building their own CDNs or whatever, they were still talking about people watching sort of time delayed kind of programs. Now, increasingly streaming is live. Everything that you're talking about facilitates that, right?
That is correct. I mean, I can't really get into that. There's a big streaming company that we're, friends with. They're working with some architectures and things. But it applies to everything, as you said. It isn't just one thing. It's everything. It applies to whatever it applies to. And there's no reason why the city of Wichita or other cities that are on our map that, appeared to us that we diligenced deeply. There's no reason why those cities shouldn't have a local internet exchange that's neutral, that's professional, that can have shipping and receiving and tech support and NOC service and deal with card swaps and reboots and run jumpers and, help them build their network more intelligently and create new interconnection sites away from the legacy interconnection sites that are very dense, very expensive with their annual escalators and, monthly cross-connect fees. Don't get me started. And the cost of power is a big problem. I see inference and agentic cluster concept designs trying to get into, existing cities. It's very hard to find. There's no white space. I think everybody's known that for a couple of years. What white space is built and available that's got, multiple megawatts? It's all gone. So now that's got to be built new from scratch. But the problem is the companies that run the GPUs, they don't build buildings. They have to get somebody to build a building. And then it becomes the supply chain. You got materials, delays, whatever, all the parts. You You got labor shortages, no skilled electricians left in the whole damn country to do these big giant projects. And now we have NIMBY. And NIMBY's a real serious thing. It needed to be taken seriously by the data center industry years ago, and they ignored it. And now it's sitting in their lap. And, paying lip service to it and making an announcement like you're going to give back now that you've been put on the spot. Unfortunately, the local communities aren't buying it, and they're pushing back. And I'm here to bring the internet to those towns and be very respectful and tasteful and not piggish about, what we want, all this land and power and your substations and whatever. People are scared. They think that they're going to have blackouts and brownouts, the water issue. A lot of places did these big deals and gave abatements, and then, they found out later how much water the building used, and it's like more than the whole damn city. We're not building anything near that. We don't say data center, and we never say megawatt. We build kilowatt size facilities. Sounds like light bulb, and it's like it's small and non-threatening. But here's the thing: City of Wichita, again, we're trying to help serve the enterprises that are there. Again, I keep bringing up Airbus and Textron. We've met them; they're there, and they're the companies that have the jobs. And then we want to help them stay there. But in order to help them stay there, they have to have much better network performance. Much better. Like Boeing. I mean, everything's digital. Everything's going to become robotic. Everything's going to become latency sensitive, or is already. The deployment of this will require a neutral physical meet point to house all the different networks and all the different workloads that need to come and meet in these places to make it work. And the people that are running layer 7 stuff, they don't want to have to think like there's no layer 0 place to put their stuff. They don't even realize. They're like, well, we just ship it there. I know a story, which I can't exactly say who it was, but they shipped a cloud to this place. And the people that were receiving it go, what are you talking about? Well, there's a tractor trailer.
What do we do with this?
The cloud. They're like, but it's the cloud, right? Don't we just get like a link and a password? They're like, where do you want us to put your private cloud? They're like, what? 150 kW worth of stuff in racks that has no place to physically go. So massive disconnect between, the physical reality and what people expect the easy button to be like,
Right. Yeah, that is, that's, again, this is like very much in line with our mission here to make sure that everybody's always talking about layer 7. Layer 0 has to be there first, right? It's like, that is the way it works. It works in that direction, not the other direction, right? So
I think part of the problem, I love it. Geography. I love it. Geography, physics. It's so in line with me too. But like, here's the problem. Humans didn't build the earth, yet we live on it. So like, who built the earth? What are you talking about? Like, you're on it. Yeah. Well, it's just here. That's the mentality. It's whatever I need physically is just there. Like, you want to drive? There's a road. Can you drive where there isn't a road? No. So you just don't drive there. Well, that's cities that don't have exchanges. You just don't go there because there's no place. That needs to change. We need to be very, as myself and Connected Nation as partners are, very, diligent and deliberate about identifying places, educating and bringing it to them. It helps their economy. It helps their network service. So many of these big giant data centers went in and took land and power and water and abatements and whatever, and never once did they think about, and this is what we're going to do for your local internet. We're going to take a router and have our AS, and we're going to get a port on a local exchange to improve the local connectivity, at least for the part that we can do. Wasn't even mentioned, which is also ironic that so many billions of dollars are allocated from the federal government, state governments, for fiber to the home, where there's no local exchange in the state. So you're funding fiber.
You get all this massive amount of bandwidth to the end user, but for what? Right. Yeah.
Right. It's like, listen, if you're going to give them free money to build fiber to the home, mandate that they have to have a port on an exchange in your state. Well, if you're smart, keep local traffic local. I think HIPAA and SOC and data sovereignty and all that sort of requires it. Yeah. So your records aren't leaving the state and all that. But if you're a state that doesn't have even one exchange, you need to have one. And then you should say, get connected to this. Everybody that's got a license to operate a telecom network in any state that has layer 3 should be required to connect to the local exchange to keep data traffic local. It will instantly reduce cost and improve service. That's really what they're supposed to be doing, right? Isn't that what the grant money's for? But again, without that being identified in the grant, that it's a network element, IX and IXP. And let's, again, I didn't mention that, but the delineation and definition between an internet exchange is an actual layer 2 Ethernet switch. And an IXP is the room or building that it's in. Those two terms have been conflated over the years. They cannot possibly mean the same thing, or there wouldn't be two terms. And if you look at most of the IXs in the world, like DKIX, who I work with, DKIX doesn't end in the letter P. It's DKIX. It's not DKIX, right? So the P is the building. I'm the building, the exchange. But anyway, creating the definitions of those and then making them define network elements in grants and then grant eligible for funds has been what I've worked with Connected Nation on for many years. But now we're skating in a different direction. We're skating to where the puck is going to be, because now the wonderful tailwinds of low latency inference AI are here. And they're hey, you, hey, you guy building that thing, we need to be in there. And it's like, all right, I'm glad you guys came along when you did. There's more to do, so much more to do. And I'm excited about it. It's going to be a lot of work, but when we're done, things are going to move. And
absolutely. And to wrap it up in that sense, I think that, when we want to move those NIMBYs to a YIMBY, right? I think that part of the argument you're making is key to it, that, in the end, these megawatt data centers, like, not really creating tons of permanent jobs in these communities and that sort of thing. But what is this, like, very well functioning internet that has these knock-on effects for education, for enterprise adoption, for all kinds of things. So, I think getting this message out there in the industry, I know you're speaking at conferences, you're here on the podcast, is going to be what one of the key messages we need to hear over the next couple of years here. So.
Yeah, well, thank you. I appreciate it. Thanks for having me on the podcast. Happy to do it anytime. And I totally agree. The sticky factor of keeping the companies that you have there with the jobs that you currently have there, letting those companies have a chance to thrive and participate in what's coming, requires a local exchange point that runs all this local inference. But certainly any state or region or county that wants to attract businesses, companies that actually do things, that create jobs, if you do not have a good network interconnection story to tell, then you're not in the same class of the story of the regions that do have that story.
Yeah, and absolutely. Or you're creating
checkbox,
creating massive headaches for their beleaguered network managers.
Well, who wants to be in the middle of nowhere where you got to backhaul 1,000 miles and the latency doesn't work and the cost is ridiculous.
Yeah, excellent. Well, Hunter, this has been really fascinating, and really appreciate your unique sort of insight to this aspect of the industry. If listeners want to keep up with you and your work, where should they find you?
Newby-Ventures, NEWBY-Ventures.com is my site for my family office and the directed investments that I make. And then I created New Ventures Research, which is the API I was referring to in all my articles and history. And now there's Agent AI Hunter that you can actually go talk to. Nice. Ask me questions. It's interesting. I get the little updates every day when people ask questions and what they are. So I learn what people are thinking. And it's trained on all of my work. It doesn't just like swallow the whole internet and all the garbage that's out there.
Right. So that's the key. Yeah.
It's my 25 plus years of writing, and all of my articles, all of my presentations, anything I ever said in this industry, it was trained on, and then it interviewed me. And the interview became a book. So you can read the book is chapters. It started asking me, like, when did you start doing this, and why did you do that? And then what happened, and what happened next, and why this and why that? And it was really interesting. And it's a combination of 3 AIs, like one that checks with 2 all the time to keep the bias out of it. Because the first one that we worked with, I won't name names, but it was horribly and now it's much better. And I train it. It sends me articles to read, and I talk to it. And it's trained on my data, my research, which is updated daily. So I pull the PeeringDB through the API. And Yeah, the daily updates, it's really fascinating to see how the internet is growing and what data rates are looking like because of AI.
Yeah.
So yeah, that's where you should go to keep up. Get on the newsletter or talk to the AI, whenever you want, whenever you're comfortable.
Yeah, that's really cool. It's one of the first actual implementations of the persona AI kind of thing that I've seen. So yeah, well done.
Well, thank you.
Excellent. All right. Thank you so much, Hunter.
Great talking to you. Take care. Bye.
Cheers. Thanks for listening. Telegeography Explains the Internet comes from the experts here at Telegeography. It's edited and produced by Jane Miller, and it's hosted by me, Greg Bryan. And I also wrote that theme song you're listening to right now. To learn more about our data, jump over to telegeography.com, and we'll see you on the internet.